I'm going to jump in here on this Monday night, and we're going to talk about chapter 1.10 in your textbooks is about primarily, excuse me, primarily it's about these things called scatter plot graphs. Okay. So, in your notes, if you just write chapter 1.10 scatter plot, that's going to be a kind of a key concept that I'm going to kind of go over here with you. That these are graphs or charts. We talked just in review. Okay, speaking of getting you ready for the next exam here, we talked about various kinds of charts, and we talked about a pie chart. Looks like a pie, and it shows little slices of the pie. And pie charts were best for comparing the little slice to the whole percentage of the whole piece. Okay, and so we talked about that's what a pie chart's best for. Okay, we also talked about the fact that we talked about bar graphs and I said to you guys that bar graphs, okay, they're really nice for comparing parts to the other parts. Okay, and let's say, go ahead and turn your mic off if you joined our class late. Just go ahead and turn your mic and camera off, okay? Thank you. Um, on this example, this is a bar graph. We've got bars. And we talked about, we said in our notes that the bar graphs are best for comparing parts, like, hey, this part here, this is compared to all the other parts, okay? Whatever restaurant this is, they're doing better than all the rest. Whatever restaurant this one down here is, they're doing the worst or they're not having as much sales. Okay. So the bar graph was best for comparing part to the other parts. Pie chart best for comparing the part to the whole. Okay. And then we also talked last week about this thing about line graphs. Okay. And they are a graph where something's in the line, and they're best for showing, if you want to add this to your notes again, we put it in there last week, change over time. Okay. Change over time. If each one of these represented hours of study, and for every hour of study, it affected your grade, they show change over time. Okay, that's what they're best for. Okay, so you've got part to the whole, part to part, change over time, and then tonight in this particular thing called scatter plot, the reason why they first of all call it scatter plot is you'll often see little data points kind of scattered, looking like they're scattered across the chart, okay, or graph. To give you another example, don't worry about copying this down, but I've got a chart that says what your car says about your salary, and supposedly people that make 50,000 or 100,000 or 150,000, this is how much they spend on their cars. Okay, now I can tell you right off the bat that I am way cheaper than this in whatever salary I make. I do not spend, I always get used cars. But you'll notice that you've got these dots, they're kind of scattered, and they represent data points. Okay. So if I go back to my previous slide, this is a key concept here. So what is a scatter plot best for? Okay. And they are best for showing what I have in yellow on this right in the middle of the screen. They're best for showing the relationship between two variables. Okay. And I'm going to emphasize that here in a moment, but make sure you have in your notes that a scatter plot is best for showing a relationship between two variables. And those variables are the X variable and the Y variable. Okay. So if we take a look at my chart here, years of experience, it says, okay, and a dependent salary, which means is the salary. So let's say, you're starting off as a police officer, or let's say you're starting off as a dental assistant, okay? In the first year of experience, you make $40,000. That'll be your starting salary. After 2 years of working as a dental assistant, your second year you'd make 50,000, which by the way is a nice jump. 3 years, it's somewhere between 50 and 60. 4 years, it looks like it's 60,000 a year. And then at 5 years, of being a dental assistant, you jump up to 70, 80, looks like around 90,000, if I kind of spelled that in here, a year as a dental assistant. Now, these numbers, by the way, are not accurate to the occupation of being a dental assistant. They might, be to like being a dentist or something, but they probably start higher, but then go higher. But the reason why I wanted to show you this example and talk about salary is in this particular case, at the 5-year point, you'll notice it's not straight in a line here. It's not a straight progression in increase in salary. There's a jump. By the way, I went on a tour of Boeing with a group of students a couple of summers ago, and they were begging for these young men and women to just apply. And one of the things that they pointed out is they had a starting salary where you work for so many years, but at your 5th year, you literally jumped up to 90 grand a year at Boeing at this plant in Everett. This is basic starting salary position. You start off, but at the 5th year mark, that was a magic number. And one of the persons that I knew, I think it was one of the students, he said, hey, my wife's they're kind of excited because this is going to be her 5th year. And so big jump in pay for her. So anyway, so to get back to this thing about showing relationships between two variables, that X and Y, these are both variables. And we know that the X variable, we learned in this class, about week 3, the X variable is the thing that's along this horizontal axis, okay? And the Y variable is, I have a Y right here, is what things that fall along the vertical axis, okay? And so like, for instance, if I go back to what I was just talking about, my 5-year, this relationship between the X variable, 5 years, and the Y salary, there's a direct correlation. There is a direct relationship between those two variables. That if you work at the end of your 5th year, you're getting this much money, okay? At the end of your first year, the X variable is tied to a direct Y variable, 40,000. And so it's a direct relationship, okay? 1-to-1, the X to the Y. And so that's what we use scatter plots for in this kind of chart, is to showing how one variable affects exactly the Y variable, okay? And that would be similar, don't worry about copying this, but in this example, they're saying that, people who make about $50,000 a year spend somewhere between 20 and 30,000, on their cars. There's a direct 1-to-1 relationship of the X variable salary affecting the car price, okay? All right. So anyway, those are the key concepts of chapter 1.10, so chapter 10 in a sense. Not a lot of new material there, but it's just an introduction to scatter plots. It's going to have you do various questions related to it. It's going to ask you about the X variable and the Y variable. So that's why I really hit on those in talking to you about that chapter, okay? All right. This next chapter is all about conversions of units of measurement. And I don't know if you remembered back when you were in school and they ask you, convert grams, 3 grams is how many milligrams, and this many feet is how many miles, and you'd have to know how many feet there are in a mile and convert it and stuff. So this chapter in the textbook, their explanation of how do you figure out conversions, of things, was more than a little bit complicated. So I got to thinking about it one evening as I was preparing for class. And I thought, is there a way I can figure out like a chart system that if you just follow the chart, you'll get it right every time, as long as you know whether you're going from larger to smaller, or smaller to larger. And I actually came up with kind of a visual chart system that I'm going to introduce to you over the next couple of minutes, and then I'll probably let you out of class early tonight. So in your notes, I want you to write the idea that when you're converting a larger unit of measurement, okay, so I can just write this above this. This is a larger unit of measurement. All right, to a smaller one, okay? Then what you're going to do, and you want to put this in your, make sure this is real clear in your note, when you're converting larger units to smaller units, okay, let me give you an example. I've got 3 yards is how many feet, okay? Well, we can kind of know that in our head, well, a yard is 3 feet, so 3 times 3 is 9, okay? We kind of can figure this one we could do right in our head. But I want you to notice the point that we're converting larger yards, that's a bigger unit of measurement, to feet, okay? So when you go from larger to smaller, to smaller, you're going to use this, you're going to multiply using my chart system. And so I want you to have that. Converting larger to smaller. And another thing I told 1/4 of my class, larger, that first unit of digit, to make something larger, you multiply it, okay? And then to make that first unit, the first thing, if it's from smaller to larger, you're going to divide. But if you make something smaller, you divide it. So anyway, so here's the system that you would put it in, okay? And you'll use this for your homework as well. Let me choose a color that's going to actually kind of show up a little bit here. I guess I'll pick this kind of bright red here. So 3 yards to 3 feet. So what you need to know is, okay, 1 yard is how many feet, okay? And so in this case, you'll give, in your homework, you'll be given a chart to look at, to go grams to milligrams and this kind of thing. And then also you can easily just take your phone out, go to Google, and then just type into your phone, converting yards to feet or grams to milligrams. And your phone will tell you in Google that 1 gram equals this many kilograms, 1,000 kilograms. Okay, it'll just tell you. And so then now you'll be able to plug it into the chart. Okay, so 1 yard equals 3 feet. Okay, all right. So now, basically, in a sense, what we're done is we're kind of done with our chart here. And so what I'm going to do is I've got this here. I'm trying to figure out how many feet that is. Okay. And so the rule says I'm supposed to multiply 2 numbers. Well, let's look at what's left to multiply. Just think about what I have in these 4 squares here. I can't multiply the feet because this is a question mark. We don't know how many feet it is, so that's not going to be an option to multiply. And you don't want to multiply the 1 because you know that anything times 1 is 1. So what's left to multiply in my little 4 square chart? I've got these 2 things here, 3 yards and 1 yard is 3 feet. I've got these 2 3s here to multiply. And so if I multiply 3 times 3, I get 9. And then the answer is 9 feet. Okay. So that's my magic chart system that works every time, as long as you copy it down in your notes correctly and think about, okay, what are my units of measurement? What are they comparing? Let's look at another example. Okay. 4 feet equals how many inches? So if they ask you me this question, here's the first thing I'm going to think: feet. Okay. I know that a feet is, okay, that's 12 inches, is 12 inches. This is my smaller, okay? I am going from larger, feet is my larger unit of measurement, to smaller. And that, we know the rule is when you're going larger, okay, to smaller, you're going to times, okay? So I wrote it out in my chart, and you can take your time and copy this down here. It said, it had the question right here, my question: 4 feet, how many inches? 4 feet equals question mark on inches. We want to know. We're trying to solve that. All right. So at this point, what I did is I just looked at, okay, 1 foot. What is 1 foot? I know that and it might be in my chart for my homework, or you might have looked at it on your phone. 1 foot equals 12 inches. So I just fill this in. One of these, this unit of measure, one of these is 12 of these, okay? And then I know that I'm going from larger to smaller. So, and if I just take to illustrate this visually again, okay, look at my box, my 4 square here. What is left to multiply? Okay, I kind of like parse it out like this. What's to multiply as far as numbers? Well, I know I'm not multiplying the question mark, and I know I'm not multiplying the 1. I'm multiplying these two. 4 times 12 is 48, so 48 inches, okay? So again, those are 2 examples showing you how to convert larger units of measurement to smaller units of measurement, okay? And so that could be grams to kilograms. It could be, it could be, I don't know, miles to feet, or it could be any number of things, okay? All right. Now in your notes, I want you to take a moment and copy down, what do you do when we're going to go from smaller units to larger units? Okay, this is the opposite direction of conversion. Okay, smaller units to larger units. And so in your notes, you want to be sure and copy down, like I have here on the slide, that when you're converting smaller to larger, you're going to divide. Okay, that's where you're going to use division is going to be your magic ticket to figuring out the chart. Okay, and I will say this again, as I've mentioned to 1/4 of this class, converting smaller. Okay, one way to think about it, how do you make something smaller? That's my first unit of measurement. To make something smaller, you divide it up, right? That's how you make something smaller. To make something larger, if you're converting larger to small, larger, you multiply. It's something, you're making something larger, okay? So that's another way to kind of think about it. But the rule is, and by the way, you'll have this in your homework tonight and all week to just use this chart. You'll also have this for the exam, and we'll also go over this with it in, write out the notes right next to the problems in the practice test. Okay, so if they had the example, convert 120 seconds to minutes. Okay, I'm thinking about the question. This is a seconds, minutes. This is larger. Okay, minutes are a larger unit of measurement, and this is the smaller. Okay, I can just look at those and see that I'm going from smaller to larger. Okay. And since I'm going from smaller to larger, I'm just going to write out put it all in my chart. I'm going to put it all in the box here, okay? So if I take 120 seconds, okay, that's what it just said in the question, equals how many minutes? They want to know minutes. And that's why I put a question mark here for minutes. How many, okay? Then I'm going to do the 1-to-1. Okay, well, how many is 1 minute? I know is 60 seconds. Okay, just looking, I could look that up on a phone. I could just know that in my head. Okay, that 1 minute of my larger unit of measurement is same as 60 seconds. So now what I've got here, again, illustrating my 4 square magic box of 4 square here. Okay, I know I'm supposed to divide. I'm not going to divide this, and I'm not going to divide this. What's left to divide? 120 divided 60. Okay, 120 seconds by 60 seconds, and that goes into it 2 times. So there's 120 seconds is 2 minutes. Okay, and that's how I just magically now use my little formula here, used my little box, my thing, and I can figure it out every time, converting smaller to larger. Okay. Here is another example. Okay, but this time using different units of measurement. We got a question that says a pill contains, okay, if I get myself out of here, a pill contains 1,257 milligrams. Mg stands for milligrams. If you want to write that in your notes, just to help you out in case you see that in a homework question, Mg stands for milligrams. Okay. A pill that contains 1,257 milligrams of an active ingredient. How many grams is that? So what they're asking for is they're asking for grams, okay? So we're comparing milligrams, the mgs, to grams, okay? So I put it in my magic chart here, okay? And I just said, okay. Now at this point, you might be going, hey teacher, I don't know, looking at milligrams and grams, I can't remember which one's larger or smaller, okay? That's where you're going to just take your phone, go to Google and type in converting milligrams to grams or grams to milligrams. And Google will tell you, it'll tell you this right here, this second line here, okay? It'll tell you that 1 gram equals 1,000 milligrams. And by the way, like a millennium, is 1,000 years in the Greek or Latin, excuse me, Latin. A milla, like milli is like 1,000, like like when they talk about a millennium, 1,000 years is a millennium. So anyway, so back to my question, it is convert 1,257 milligrams to how many grams? Punched it in my phone, and or it might be in a chart in your homework, and I can see that 1 gram is 1,000 milligrams, okay? At this point, I can see that if one of these grams is 1,000 of these, that tells me for sure this is the larger unit. Okay, I am converting smaller to larger. And so again, just going to play Foursquare here with my chart, and I'm just going to figure it out that way. And just going to ask myself, okay, I know when I'm going from smaller to larger, I have to divide. That's the rule, okay? And so I'm looking at what's left in the chart. These two things, I'm not going to divide these, okay? So 1,257 milligrams divided by 1,000 milligrams equals 1.257 grams. Bingo, there I go. I've got my grams, I got my answer. So that's another example of converting smaller units of measurement to something larger. And that turns out to be about it. So what I'm going to do is I'm going to stop my recording.